What is nice is that when you have stuff like the analogs, so what we're thinking, just straight up computer modeling and the National Weather Service, when all three of those line up, it does provide a bit more confidence than normal. I feel like this has been the case for years now, where we just have a warm west and a slightly less warm east with not much in the way of cooler weather. I guess if there was anywhere that was going to be closer to normal, it would be like the Gulf Coast, Southeast. But the thing is that it's already so hot that time of year that you're not really dealing with a cool summer. You're just dealing with a pretty average summer. So that ridge of high pressure in the west definitely going to be a factor. So we could definitely see some heat waves over there. And then what often happens is that you get that heat, it ends up getting whisked to the east. So you could be dealing with some pretty legit heat by the time you get into the Midwest and Northeast. It's also going to be difficult to get number wise very high heat, highs over 100 in places like New York City or whatnot, because it's probably going to be so wet. So you could be dealing with a lot of very muggy hot days, but the odds of you getting highs in the hundreds are going to be slightly lower than normal just because of how wet it is. In terms of modeling, very similar signal here. Most of the heat is going to be in the west, but you could see how when you have that westerly flow, it gets pushed into the east. And then, although not particularly cool, we do see that heat start to subside by the time we get to the southeast. And again, the National Weather Service largely agrees. It is a little bit different. Like they have a somewhat less hot signal in the upper Midwest, but they do have cores of heat, one in the west and one in the Northeast.